If not, we're going to start recording for now, and we're going to go back to population ecology. We should finish that up today and probably not till Monday, but then we'll get started looking at community ecology, looking at how organisms interact with each other, things like predation, competition, parasitism, things like that. So we've been focusing on population in general, and now I want to focus a little more specifically on the human population. So you should be looking at a population growth curve graph. And this is actually a graph of the human population. Keep in mind, really, until about the 1800s, these numbers are estimates. We have pretty good estimates from what's sometimes called the Middle Ages or the medieval period, just because a lot of kingdoms in Europe and Africa and Asia took some kind of census back then. Why? Because of course they taxed people. So we do have some decent estimates of population from, maybe 1200 on or so. Before that time, our estimates are mostly based on the fact that when the Europeans started exploring the world, they discovered a lot of native peoples in various areas. And, it was much more informal than what we would consider a scientific study today, but they did kind of count how many people there were in various tribes. So we can make some educated guesses about periods prior to 1200, but those really are guesstimates. They weren't based on a census or anything like that. So if we look at the human population, we're going to kind of skip all the way over to the end. Notice that the human population is relatively stable. And then it starts increasing noticeably, maybe around 2000 BCE. If you're not familiar with the term BCE, this is before the Christian era. It used to just be BC, before Christ, but at some point, historians realized that they actually didn't know exactly when Christ was born. So to say BC or AD was a little bit deceptive. So now we typically say BCE, for before the time when Christ appears in the historical record. But notice somewhere around 2000 BCE, the population starts to increase kind of noticeably. And notice that if we go up to this time period between the year 0 and 2000 and almost over to the year 2000, the global human population hits 600 million, then 900 million, then somewhere in the late 1800s or the mid 1800s, the global population reaches 1 billion. Now, this is significant because if you look back, we'll talk more about what happened during some of these time periods, but if you look back to about 10,000 BCE, which is where our graph starts, so it took roughly, it took 11,900 years to have the human population grow to 1 billion people. But notice the human population then hits 2 billion in 1900s, in 1928. So once the population hits 1 billion, it gets to 2 billion in another really somewhere between 50 and 100 years. And then the population gets to 3 billion by 1960 in just 32 years. And then it gets to 4 billion in 1975 in 15 years. So notice we're adding people at a faster and faster rate. And if you think about this shape, this graph and its shape, this is clearly a J-shaped growth curve for a population. Now, the problem is, remember what we were talking about the other day, we had those logistic curves, we had boom and bust population curves, we had oscillating curves. But one of the things we said was, one way or another, the growth rate has to stop. It can't continue indefinitely because resources are limited. Um, and so one of the concerns that people have about the human population, which is now about 7.75 billion, one of the concerns that people have is when are we going to reach that point where the growth stops? Because keep in mind, when we think about population growth, and for the human population, something that we're looking at across the entire Earth, there's really only two factors. Somebody who lives in Canada and moves to the United States, they're still on this planet. So that is not really immigration or emigration on a worldwide scale. So the only thing we have to think about is birth rate and death rate. Well, there's only two ways that the population growth rate can decrease. Either the birth rate drops or the death rate increases. And what we see when we study other populations in nature is that populations that have very high birth rates tend to end up with very high death rates. So I'm not sure this is how we want to, balance the Earth's ability to support people, is by having a lot of people born and a lot of people die, perhaps young. So if we look at the human population of 7.7 billion right now, a little bit over, a lot of people think this is beyond the carrying capacity of the Earth. Remember, the carrying capacity is how many individuals that the environment can support, essentially for an infinite amount of time. And a lot of people think we're already beyond that with people, and that's why we have so many problems with many species being on the endangered list, with pollution, with all sorts of issues. Some people think that the Earth can support many, many more people. One of the things that isn't clear is it's not clear if the Earth can support 7 billion people at the current level of living that we enjoy in the United States. The Earth might be able to support more people if everyone's willing to become a vegetarian, if people are willing to give up driving in cars, flying in planes, if we use walking and bicycles and things like that to get around for the most part. So part of the question with any environmental problem is there are always some trade-offs. What are you willing to give up to solve any particular environmental problem? So let's move back to our map. And prior to about 10,000 BCE, before the Christian era, most human cultures lived as some form of hunter-gatherer society. Now, hunter-gatherer societies were able to be studied because when the Europeans started exploring the world, they encountered hunter-gatherer societies on many different continents. And in hunter-gatherer societies, as the name suggests, they get most of their meat by hunting for it. The traditional view has always been that men probably did most of the hunting because, men are stronger. So if somebody's out there killing the saber-toothed tigers, you don't want it to be those weak women. But there has been some recent archaeological evidence that suggests that probably women participated in hunts a lot more than anthropologists have recognized in the past. So hunting was one way that these people got their food. And keep in mind, when we say hunting, sometimes hunting is really fishing, not hunting. And gathering refers to the fact that the other way these people got their food was by collecting plant material. They might dig up roots like potatoes and carrots. They might harvest fruits and berries. They might cut down stalks of plants like celery where the stalks were edible. The best evidence we have that is in these hunter-gatherer societies, that gathering probably provided most of the calories on a daily basis. Some people talk about the Neanderthal diet, and we come from people who mostly ate meat, and that's why people have trouble maintaining their weight. But actually, when anthropologists study people the further back they go, the higher percentage of their diet was actually plant material. The evidence we have from societies that were studied when Europeans first made contact with some of these peoples is that hunting provided a lot of the protein, meats high in protein, but for many of these groups, the men aren't necessarily successful at hunts very often. They might kill an animal maybe once a week. Now, when I say an animal, a large animal, they might kill squirrels or rabbits or catch small fish all the time, but they really only kill things like deer or buffalo, something big enough to provide a kind of a feast, maybe once every week or two. And then the people in these groups tend to kind of gorge themselves on meat. They eat a lot of meat in a short period of time, but then they may not eat much meat for the next week or two when the hunts aren't successful. Now, when we look at hunter-gatherers, they seem to have made very little impact on their environment for one simple reason. If you look at their lifestyle, you're going out, you're collecting, ripe fruit, you're hunting rabbits or deer or whatever that lives in the area. After a short period of time, the deer figure out they should avoid the place near your camp. You kind of exhaust the supply of all the fruits and the berries and the potatoes in the area. So when we study these hunter-gatherer societies, they tend to constantly be on the move. And because they're constantly on the move, remember what we said the other day, predators, you could think of people, attacking the animals or the plants in an area as predators. Predators tend to be a type of density dependent population control. So by the time the populations in one area start to get low, the group moves to a new area. So it seems like probably there were very few organisms that were driven to extinction. Probably when we look at these people, from the ones that have been studied since we made contact with them, they're gradually disappearing nowadays. But from the ones that were studied, they eat a much wider variety of foods than any modern human culture does. Because they're really just kind of scraping by. You don't find hunter-gatherers who are overweight. That type of food and that amount of food is not that easy to find. So when we look at these individuals, they eat a wide variety of, especially plant material, but even animal material that we wouldn't necessarily consider to be edible. Now, the lifestyle they lead is somewhat contradictory because they're always on the move. Imagine that you didn't have any fixed house or apartment or whatever you live in. If you lived in a teepee or a small tent that you put up every night, and if you didn't have a car or even a bicycle, if you had to carry all your belongings on your back, in most of these cultures, people don't have a lot of possessions. Why? Well, maybe the Hobbit is your favorite video, but do you really want to carry a video machine and a DVD around with you so that you can watch that movie if you had to carry that with you every couple days when you moved? You'd probably find that you could just vaguely recall the Hobbit and be just as happy thinking about it. So they don't have a lot of possessions. Now, because they don't have a lot of possessions, what we see is they really have a very simple lifestyle. And when you think of hunting and gathering, you might imagine this very arduous, this very difficult lifestyle. But most studies suggest that people who live in hunter-gatherer communities have more leisure time than people in any other type of human culture. Why? They don't have a lot of possessions. They don't need to work so that they can buy the newest pair of Air Jordans, or, skirts were long last year, now short skirts are in fashion. People don't have to shop for things like that. So as a result, they find enough food to satisfy themselves. They don't work to pay taxes. They don't work to, keep up with the Joneses next door. So as a consequence, they have a lot of leisure time. They spend a lot of their time sitting around the campfire, telling stories, basically what we would consider playing. Um, uh, However, around 10,000 BCE, something happens that changes human society. So we have these hunter-gatherers, and what we see is when we study them, everywhere they live for a few days or a week, they have a trash pile. You know, they eat an apple, you got to have some place to throw out the apple core. So all their trash is deposited in kind of one place in a little trash heap. Now, at some point, and in some parts of the world, it started around 10,000 BCE. In some places, it started a little bit later. Something called the agricultural revolution occurred. We think that probably it was due to women because, women always get stuck with the housework. In these groups, we think that probably what happened was, if you throw away an apple, what might happen? Well, the part of the apple that you throw away probably has the seeds in it. So if you're in a spot for a little while, you might notice some plants growing out of this trash heap. And somewhere around 10,000 BCE, people began what we call domesticating plants and animals. People began to realize that, hey, instead of wandering around and finding a tree that had apples on it that were edible, you could plant an apple tree. Now, the downside is if you plant an apple tree and you really want to, use the resources to their maximum efficiency, you've got to stay in that area for a while. So around 10,000 BE, with the invention of agriculture, people had a steadier supply of food. So one of the things we see is that the birth rate increased and the death rate decreased. So notice that since the population growth rate is birth rate minus death rate, that would cause the population to start to get larger. But at the same time, the population is confined to one area. If you have a field of wheat planted, you can't walk away and leave that wheat. If you do, nobody harvests it, it'll all rot or get eaten by mice. So people were confined to one area. And because of this confinement, people started having a bigger impact on the environment. A good example is a country in the Middle East called Lebanon. If any of you know about the flag of the country of Lebanon, Lebanon has a cedar tree on their flag. But if you look at the country of Lebanon, Lebanon is a lot of desert for the most part. So why do they have a cedar tree on their flag? We have pretty good evidence that if you go back 12,000 years ago or so, most of Lebanon was covered by a cedar forest. But when people stayed in one area as the population grew, trees are good for fires, they're good for making buildings. So the forest gradually disappeared. And we see the same thing around the world. I don't want to just pick on that region. When people started staying in one location, they began having much bigger impacts on the local environment and causing a lot of the problems that we think of today. Today we talk about deforestation of the Amazon, cutting down the trees. But deforestation started a long time ago when humans settled in one location. Now, in an agricultural society, remember what I said, the birth rate was relatively high. The death rate was relatively high. A lot of people died in childhood. So having a big family in an agricultural society was really a good thing for a couple of reasons. First of all, if you have a big family, if you have more kids, your kids could work the fields. And the more land you can work, in a sense, the richer you can get. So having a large family was beneficial. And kids didn't have to go to school, so you didn't have to worry about, paying college tuition for 10 kids. If you had 10 kids, that was just more hands to work in the field. Having a big family was also important because if we go back during this time period, there's no equivalent of Social Security or a retirement pension. So how do you survive in your old age? Because eventually you're going to become too old and feeble to work the fields. Well, the way you survive is your children take care of you. But if you have 10 or 12 kids, probably 5 or 6 of them are going to die before you do. And you might not get along with 1 or 2 of them. So having a lot of kids is also beneficial. This is your Social Security. And so we see that families during this time are very large. And there are a lot of deaths of young individuals. However, in the 1600s, in certain parts of Europe, some places it comes later, some places in the world it's really just getting there now, something else occurs, something that we call the Industrial Revolution. And basically the Industrial Revolution substitutes machine power for what used to be muscle power, either human muscles or the cows that you were using to pull the plow in your field. But machine power starts to supplant that. And machine power is much more efficient in the sense that if you have a John McCormick reaper, you can harvest much more wheat in a single day than you can with a wagon pulled by your cattle or your oxen or your horses, whatever you happen to have. So again, notice the food supply increases during the Industrial Revolution. Now, because the food supply increases, even in an agricultural society, there are people who are malnourished. So again, a better food supply increases the birth rate and decreases the death rate. So the population starts to increase even more dramatically. So notice if you think about 1600 or 1700, depending on where you are in the world, we're somewhere around here where we're at the point where the graph starts to go up noticeably. Now, notice because the same amount of land can support more people when you're using machines to plant the seeds and harvest the wheat, this means the carrying capacity is increased for people because the environment can support more people. And in fact, the carrying capacity is increased during the agricultural revolution at 10,000 BCE, because if we're using agriculture in an area, the land can support more people than it can if the people living there are hunters, gatherers, and have to move around. Now, keep in mind, although I just said agriculture increased the carrying capacity, the Industrial Revolution increased the carrying capacity, there is one thing that we have to recognize. Remember that the carrying capacity is the size of the population the environment can support forever. So there are a lot of people who argue that when we look at the agricultural revolution and when we look at the Industrial Revolution, they didn't increase the carrying capacity of the earth very much, and that we're already way over the carrying capacity. It's not clear if that's true or not, but there are some people who argue that. Now, one of the problems with the Industrial Revolution is after the Agricultural Revolution started, it kind of started in 3 or 4 places around the world at roughly the same time. The one that's most famous is the area that we call Mesopotamia in the Middle East, but there are some places in Africa and in the Americas where it appears to have started, the same time, give or take 500 years. But with the Industrial Revolution really started in Europe and in North America and gradually spread to other places. And as a result of this, this has created some of the increase in the world population that we see today. Think about countries in South America or Africa or Asia that may have been predominantly agricultural, and what would happen when they came into contact with European civilizations that were industrial. Well, remember what I said. In agricultural societies, it's good to have a large family. And in fact, in the religions of most agricultural societies, the religion tells you that one of your duties is to have children, for the religion, but also because it's good for your society. If you don't have enough people, you can't harvest enough grain, you starve. So a lot of times, the idea of having a big family becomes ingrained in the religion. Think about Catholicism. Catholics aren't supposed to use birth control. You know, so what's the problem? Well, when a culture where the religion says that you should have children comes in contact with an industrialized society, that religious obligation or duty to have children is very hard for people to lose. But something that does happen when an agricultural society comes in contact with an industrial society is the industrial societies, part of the Industrial Revolution, is the development of better medicines, of pharmaceutical drugs like penicillin, of surgeries. So guess what? The birth rate in an agricultural society stays high when it comes in contact with an industrial society, but the death rate drops. So what happens? Well, what we see here, the population increases very rapidly because of the fact that the birth rate is still high. If you're still having 10 or 12 kids, but now they all survive, guess what? Population increases very rapidly compared to, in the good old days when half your kids died. So this is one of the things that we see reflected in the graph of the human population. Now, at some point in industrialized societies, we think it probably happens in all of them, but we're not sure because some societies have gone through another revolution and some haven't. This last revolution is sometimes called the demographic revolution, or sometimes just the demographic transition. And the demographic transition is really dependent on how women in the society are treated. Because if we go back to agricultural society, women have one purpose in those societies: to produce babies. In the Industrial Revolution, women start to have opportunities to work outside the job, outside the household. And so they start to get an economic value to a family. So they're not just good for producing babies anymore. And then finally, during the demographic transition, women start to get even more education and more economic opportunities outside the household. And when that happens, then women often decide, hey, there's something better than staying at home and having babies all the time. Maybe there's another way to enjoy life more. And when that happens, then the birth rate starts to decline. And so the population growth tends to level off at that point. If we look at the growth in the human population, where we see on the right side, the population is going up almost straight, almost completely vertically. One of the things we see is that if we look in countries that are industrialized, the growth rate is very low. If we look in countries that are sometimes called developing countries, the countries that haven't fully made the Industrial Revolution and especially the demographic transition after that, that's where the growth rate is. So one of the things that scientists are worried about is how to slow population growth. Because besides just the sheer number of people, if we look at today, if we have 7.7 billion people and we go back, roughly 100 years when there were 2 billion people, well, if you have 3.5 or 4 times as many people, guess what? They consume more resources. They make more waste products, various forms of pollution. There are more car accidents if you have 7 billion cars on the road than if you have 2 billion cars on the road. So bigger populations by themselves pose a problem. There's another problem. And if we look at the United States is a prime example of this problem. If we look at a country like India and we compare it to the United States. Now, in discussions of global warming, you may have heard some discussions about your carbon footprint, kind of how much carbon your various activities put into the atmosphere. But we can look at your overall environmental impact. And a person who lives in America has as much impact on the environment as about 50 or 60 people who live in India. Now, that's a problem in and of itself, that inequality, but there's another problem. If you go around the world, most people around the world want to live a lifestyle that compares to the lifestyle that Americans live. And as I mentioned before, it's not clear if our planet can support 7.7 billion people or more, because the population is still growing. It's not clear if the planet can support that many people living at the current American lifestyle. So part of the question becomes, as I said, are we all willing to give up rapid transportation? Are we willing to all become vegetarians? Are we willing to make the sacrifices necessary for the world population for everybody to survive? Or will we all just be living at a subsistence level then? Is it the type of life that people will want to live? So this is one of the concerns we have. So this part of the graph where the population grows rapidly is sometimes called the population explosion, where the population increases dramatically. And remember what we said the other day, because of this dramatic increase, and because not only is the population increasing, but every year people are using more and more resources because of those two factors, more people and each person using more resources. This is why people are probably the major biotic factor for all living organisms. Now, there are a few living organisms that like us, that do better with people around. Cockroaches, rats, pigeons, squirrels, some things like that would probably not be as common without people as they are with our cities, where we provide plenty of food for them. Some animals do better with human influences, but a lot of them don't. And one of the things we'll talk about as we study ecology, like a lot of other things we've talked about this semester, we don't understand ecology completely. But one of the complicating factors is that when we make ecological mistakes, they can take a long time to correct. And so it's not just as simple as, okay, I'll stop driving my car to the grocery store across the street today and that will solve global warming. No, some of the gases that are causing global warming are going to be in the atmosphere for several hundred years at a minimum, unless we figure out a way to remove them, which at this point we haven't done. So let's look at another reason why scientists are worried about the population explosion. This is an age pyramid for the world population as of 2015. Boys are in blue, girls are in red or pink. And look at the overall shape of this age pyramid. Notice that if you think about the pre-reproductive years, remember that the reproductive years are considered to start at year 15, at age 15. So if we look at 10 to 14, the last age bracket before the reproductive years, and if we look at 40 to 44, the last year in the reproductive years, notice that we are going to have, for several years to come, more people moving into the reproductive years than are leaving the reproductive years. And that's something that's typically characteristic of what? A population that's growing. So it's going to be very difficult to stop population growth. And that's partly because remember what we've talked about with living organisms in general. What's the strongest drive that living organisms have? To reproduce, to pass their DNA down to the next generation. So it's going to be very difficult. You know, it's hard to convince people maybe you shouldn't have children because it might be really bad for your grandchildren. We'll worry about that later, not right now. So when we look at this, we want to keep in mind that the human population is currently still growing very rapidly. So let's look at some examples of how rapidly population growth is occurring. So let's go to another screen and look at some numbers. And you should be able to see a chart now of a variety of populations in the Chicago area. We're going to go back for a minute and look at some other data. So first, let's look at some data from around the world. So in 2002, the birth rate per thousand in the United States was 15. The death rate per thousand was 9. Calculate the growth rate per thousand. So if we look at the growth rate, remember that the growth rate is equal to the birth rate minus the death rate. And we're talking about per thousand. So in this case, our birth rate is 15. Our death rate is 9. And so this is 6 per thousand. Now, we can also express this as a decimal or a percent. So let's think of expressing this as a decimal. 6 per thousand. Remember that for our decimal, the first column is tenths, then hundredths, then thousandths. So we could express this as 0.06. Or the other way we could express this is as a percent. And remember, percent is out of 100. So when we're talking out of 1,000, this is really 0.6%. If it was 0.01, that would be 1%. Think back to some of our discussions of frequency earlier in the semester. So we could express this in any of these ways. This would be fine. Now, the next question says, calculate the doubling time for the United States. Okay, so for the United States, depending on what we want to use, remember we said there's that thing called the rule of 69. If we want to use a decimal, we're going to do 0.69. And we're going to divide that by 0.006. Oops, not comma 006. Now notice numerically, if you don't want to do that, this will give you the same answer as 69 divided by the percentage. So you could take 69 divided by 0.6. So if we do this, we come out with about 115 years. Now, notice, why is this years? Because this is the rate that we're working with for people unless it tells us something different. And we'll actually look at a problem in a little bit that gives us a different unit of time. So this would be 115 years. Now, that's not too bad. But notice it still means that we have a lot of work to do. Let's look at a country that has a higher growth rate. So let's look at the growth rate in Mexico. So the growth rate is still birth rate minus death rate. So our growth rate here is 26 minus 5. Now notice that the death rate in Mexico is lower than the death rate in the United States. And sometimes you have to be careful how you think about these numbers. You might think this means that Mexico has a much better healthcare system, and they might, but this doesn't really prove that. The reason this doesn't prove that is, think about those age pyramids. We don't know what the age pyramid of the United States and Mexico look like. So it's possible that the death rate is low in Mexico because there are a lot more young people. If the United States has a lot more older people, the death rate could be higher, but it doesn't necessarily say anything about the medical system. So if we do our subtraction, the growth rate is 21 per thousand, or, if we want to think of the other ways we could express that, it's 0.021, or it's 2.1%. So what's the doubling time for Mexico? So we can take 69 divided by 2.1. And usually I like to use the percentages just because, if you start dividing with the decimals, I think it's more likely at the end that you're going to misplace a decimal. But whatever you feel comfortable with is fine with me. So if we look at this, what we see is that oops, didn't mean to put the 0 in yet. If we divide this out, we get about 32.8 or 9, I'm not sure. And again, our units are years. Now, this is a good example of why the doubling time can be important to know. Think about what this means when we look at the doubling time. Now, we do have to keep in mind what I've mentioned before on a couple of occasions. Since we're dealing with humans, cultural norms can change in 30 years, and the birth rate could go down. Probably the death rate won't necessarily go up, but it might as the population ages, if it's a young population now. But think about this in another way. Suppose this doubling time holds. If this doubling time holds, this means in 33 years, Mexico has to have twice as many hospitals. They have to have twice as many police stations. They have to have twice as many schools. They have to have twice as many highways. They have to have twice as many health clubs. They have to have twice as many of everything. And if they do have twice as many of everything, conditions won't improve. They'll be the same, because there's twice as many people. An example that usually hits home is IDOT, the Illinois Department of Transportation, did a study of traffic in Chicago in the year 2015. And their prediction was, keep in mind this was done 6 years ago now, but their prediction was in 10 years, in 2025, there would be twice as much traffic on every Chicago expressway at every time of the day. So, if you've ever been on the Dan Ryan and you've been muttering under your breath at that idiot who just cut across 4 lanes to get to their exit, there's either going to be twice as many cars that they're cutting through, or somebody will come up with the idea and they'll be cutting across 8 lanes of the Dan Ryan because we'll expand it. But neither one of those is really a good solution to this problem. So when we look at the doubling time, sometimes you see 20 or 30 years, and that seems like a long time. But if you think about what has to be done in that 20 or 30 years, imagine building twice as many hospitals, schools, police stations, highways in 30 years. That's a pretty hefty task. I'm not sure there's any country that can afford to do that economically. One country for about 15 years actually had a doubling time of 8 years. 8 years, imagine that. That means if you were 16 in that country, by the time you were 24, there were twice as many people. And there were 4 times as many people as when you were only 8 years old. I mean, that's incredible. Their growth rate has slowed now, thankfully, but that is a potential problem. Now let's look at some data where we're thinking about percentages. So here's one example. The growth rate for the world human population is 0.014 or 1.4%. Notice in this example, they didn't give us the birth rate and the death rate. They just actually gave us the growth rate. So that first calculation that we were doing above, where we were subtracting death rate from birth rate, we don't have to do that. They've already done that for us. So what's the growth rate for the world? Well, we just have to take, 1.4, not 1.5. We just have to take 69, our rule of 69, and divide by 1.4. Or again, if you like, keep in mind you can do 0.69 divided by 0.014. You should get the same answer either way. And in this case, you're going to get just shy of 50 years. So notice in 50 years, worldwide, we have to have twice as many hospitals, twice as many schools, twice as many everythings. And people won't have better access to medical care or to school or hospitals, whatever we're talking about. Things will be the same level they are now. They might be distributed a little bit better. Maybe we won't have such a gap between the rich and the poor, but overall, it will still be a potential problem. So here's some data from 2 censuses, the 1990 census and the 2000 census, for Chicago and some other Illinois areas. So it tells us the population in 2000, it tells us what the population was in 1990. So then the types of questions that we get asked about this are, okay, do any of these areas show negative population growth? So did the population anywhere go down in this 10-year period? Well, if we look, notice in Chicago Heights, the population went down from a little bit over 33,000 to 32,700. So there are some areas where the population declined during this time period, and there are some others. So population, even though the overall human population is increasing, it doesn't mean that the population is decreasing, is increasing everywhere. So then there are some other questions about, did any of these populations double? What were the largest numerical increases? And then which 3 areas showed the largest growth rate? So let's see how you would calculate growth rate. So let's take Blue Island, for instance. And let's calculate the growth rate in Blue Island. Okay, so here's our 2 numbers. So this is our 1990 population. And here's our 2000 population. Okay, so let's look at the growth rate. So for the growth rate is the 2000 population minus the 1990 population. I guess I should put these in parentheses. And then we're going to divide by our starting population, by the 1990 population. So in this case, our growth rate is 23,463 minus 21,203 we're going to divide by that 21, oops, 203. So if it was just asking us what the increase in population is, we wouldn't divide. We would take 23,464 minus 21,203. So, you know, if we did that, we would get 2,261. That's how much the population of Blue Island increased between 1990 and 2000. Now we're going to have to divide by the original population in order to figure out what the growth rate is. So if we look at our growth rate, and notice you might be able to tell, depending on how good you are at math, 2,000 is about 10% of 21,000. So this is going to be somewhere around a 10% increase. It looks like it's going to be a little bit higher, but you know, if you can estimate, the nice thing is then when you look at your final answer, you can kind of get an idea whether your final answer is in the right ballpark or not. Okay, when I divided, I got, I'll round off to the first decimal. So I got 10.7%. Oops, I didn't want to put a plus there. 10.7%, or again, if you prefer decimals, 0.107 works. Now, notice with our earlier problems with the human population, when we've been talking about growth, we've been talking about how much the population grows over a year. But here we're talking about between 1990 and 2000. So we're going to say per 10 years, or if you'd rather, per decade. So notice a 10% increase. So that's pretty fast. So so what I would like you to do, this is not going to be due till Wednesday because I think you have some plant questions that are due Monday. I will post this, and I would like you to work the problems that we didn't work. So on the first set of problems, we did 1 and 2, and then 5 and 6. So you're going to do 3 and 4, and 7 and 8. And then on this last set, actually, we didn't answer any of them completely. We talked about some of them. So notice 1 and 2 and 3, you don't have to do any calculations. Well, I guess you do. You have to take the 2000 population minus the 1990 to show which ones had the largest numerical increase. So to find the largest numerical increase, you're going to take, you know, Chicago in 2000 versus Chicago in 1990. And so that will be your answer. For this last one, you have to find the 3 that show the largest growth rate. So notice that won't necessarily be the 3 that have the largest numerical increase. So don't just take your answer for number 3 and transfer it over to number 4, and you know, your answer for number 3 would just be, if this was one of our answers, your answer for number 3 would just be the number 2261. What do you get when you take the 2000 population minus the 1990 population? Don't just carry over your 3 answers for number 3 and then assume that those 3 will have the largest growth rate. They might, but they might not. You could live in a small town, and if the population was 10 in 1990 and it was 20 in 2000, the population doubled in 10 years, but it only increased by 10 people. So the numerical increase wasn't large, but the percentage increase was very large. Any questions about these before we leave them? You will have some time if you want to ask some questions on Monday. As I say, these will be due Wednesday, but I'll post them later today. And since I'm posting them today, they'll be at the end of this week's material. Well, maybe I'll go ahead and start next week's, and I'll just put them at the beginning of next week, because that's probably where you'll look for them if you don't get them over the weekend. So if there aren't any questions, I'll go ahead and let you go and enjoy the weekend. Looks like it's going to be chilly, but sunny at least. 1 out of 2 isn't bad.
Have a good weekend.
You too, Nick.
Thank you. Have a great weekend.
You too. I'll see you Monday.
Yeah. Bye.
Bye-bye.